Chapter 5 review quiz. Can you get your quizzes out, please? I'll pause for a second while you're all finding these. This is a good summary of some of the questions you can expect to see on this test. Some multiple choice, some fill in the blank, some written. Oh, also remember then, I gave you the crossword puzzle last class. Every one of those words is going to be in a vocabulary section on the test. So I'm hoping that's kind of free marks. If you do the crossword puzzle, memorize the definitions. It's not quite free, but it's easily earnable marks. So hopefully I've stalled long enough. You found your take-home quiz. Good old Ann Serkey. All right, here we go. It says, circle the letter of the best answer. You may refer to a periodic table. So to the test, bring your pink periodic table. And to whoever's listening to this, my TOC, they are allowed to have their pink periodic table on the test, and they are allowed to have their yellow acid-base sheet on the test. And I'll give you a few extras if kids forget them, but hopefully they won't. So you can have a periodic table, and you can have your ion chart, pH scale, and pH, well, that yellow sheet. Which of the following household items is basic? Well, I go to my yellow sheet and I say, I think baking soda. Yeah, baking soda. Who knew that bananas were acidic? They are, not compared to your stomach. Compared to your stomach, they're less acidic. They're more basic than your stomach, which is why they don't give you like a tummy ache. Anyways. What are the colors of methyl red indicator and bromothymol blue indicator in separate samples of water at pH 7? You know what? First I'll look at methyl red. Methyl red at pH 7 is going to be yellowish, I think. Maybe orangish, but I think yellowish. Let's see. Bromothymol blue. Oh, that's a tricky one. Looking at my yellow sheet, it looks like that's right when it changes from yellow to blue. Now, you may recall in the lab that we did, we actually had bromothymol blue, and there was one of them that was right around a pH of 7 where it actually turned halfway between yellow and blue. It's going to turn green. So this one is wrong and this one is wrong. Bromothymol blue indicator is green. Bromothymol blue indicator is green. Well, I want to say yellow. You know what? I think it's going to be yellow, not orange. I think, oh, hang on, I'm looking at methyl red. You know what? I was looking at the wrong one. That was dumb of me. I was looking at methyl orange. Don't do that mistake. Methyl red is definitely red below pH of about 5. You know what? I suspect it might be orange. Mr. Dueck, I don't remember. If you look at your notes on acids way back here. Methyl red. Red in less than 4.4, yellow and over 6.2, and orange. You know what? It's yellow and over 6.2. It's not going to be orange. It's going to be yellow. I'm probably on your test not going to ask you one that specific. They'll be a little more, no pun intended, basic than that. So yellow, not orange. I'll give you ones that are more obvious than that. I'm not going to give you ones that are halfway between. What are properties characteristic of an acid but not a base? They're not bitter. They're not slippery. So it's either A or D. Remember, soap is a base. It's bitter. It's slippery. Sour reacts with magnesium, turns litmus blue. Ooh, wait a minute. I'm looking at my sheet. When I put litmus into an acid, it does not turn blue. It turns red. So that's correct, and that's correct. Does phenolphthalein remain colorless in an acid? Yep. D. What's the best chemical definition of a salt? Well, first of all, it's not a material formed by evaporating seawater. That is one type of salt, table salt, but no. Now, the answer is B, but I'll show you why, and I'll show you how you can get through a process of elimination. A material containing a metal ion and an oxide ion, this is what we called a metal oxide. That's not a salt. A material containing a metal ion and a carbonate ion, no, that's not a salt. That's a metal carbonate, I think. It's the material formed by the reaction of an acid and a base. We said in an acid-base neutralization reaction, you get, as your products, a salt plus water. You may even remember this terrible joke. Oh, where is it? The base is under a salt. Okay? Burning magnesium in the air, really what that's saying is combining magnesium and oxygen, because when you're burning something in the air, that's the primary reaction going on, produces a brilliant white flame and a white powder. Gotcha? When the white powder is placed in water, it dissolves. What is the color when bromothymol? So here's what we're really saying. When you mix a metal oxide, because magnesium is a metal, oxygen is oxide. When you mix a metal oxide and water, what do you get? If we go back to our salts notes, to that summary at the very, very end, and also during the notes, but we have a lovely summary. If you mix metal oxide and water, you get a basic solution. In fact, a non-metal oxide, for example, silicon dioxide or silicon monoxide or carbon monoxide, all of these oxides with nonmetals and water, you get acids. This is where acid rain comes from. And these are products often of burning fossil fuels. So you burn fossil fuels, the carbon dioxide, the carbon monoxide goes in the air. Also, there is some oxides in the earth themselves. Anyways, going back to our question, metal oxide plus water, metal oxide plus water gives a base. So if you put bromothymol blue into a base, it's going to turn blue. I got that from the yellow sheet. What's formed when HCl and NaOH are combined? This is a acid-base neutralization reaction. This hydrogen and this OH are going to combine to form H2O, which means that's wrong, and that's wrong. I think the answer is A. Let's confirm. This sodium and this chlorine will combine to form NaCl. You know what? The answer is A. And this is what we mean by whenever you mix an acid and a base, you get a salt. Now, NaCl, sodium chloride, is table salt, but any product of an acid-base neutralization reaction is a salt and water. And the salt comes from the metal attached to the base and the non-metal attached to the hydrogen, making it an acid. Which list shows the elements that are most reactive towards water? So first of all, if we look at our periodic table thingy, column 1, the alkalines as you move further down. So cesium is far more reactive than potassium. Cesium is far more reactive than potassium. Potassium doesn't come before. Which list shows the elements that are the most reactive towards water on the left and the least reactive towards water on the right? You know what? Here, cesium, potassium, magnesium. Cesium explodes. I think I showed you guys a video a while ago of that. Potassium also explodes in water. Not as quite as much. It just burns. And magnesium's further towards the middle, not as reactive because it needs to get rid of 2 valence electrons. Which of the following compounds are organic? I know this has carbon. No, it's got a carbonate. That's not organic. That's organic. That's organic. So 2 and 3 only. B. Consider the 2 representations of ethane. Looks like ethane is C2H6. What kind of representation is each? The left is a molecular formula? No. The left is a structural formula? No. The left is a ball and stick formula? No. You know what? The right is a ball and stick model. The left is a space filling model. I'm not going to ask you to draw these on your test. I will ask you to recognize them on your test. Which of the following is true of the element carbon? Carbon can form 4 bonds? Yep. Carbon atoms combine to form long chain. Yep. Yep. C. Match. Okay, each descriptor may be used only once. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. I'll still cross them out when I use them. Solvent. You haven't really talked about that very much, Mr. Dueck. Yeah, I think I'll be able to figure it out. Indigo carmine. Indigo carmine. I'm looking at my... So it turns yellow in a really, really high pH, like past 12. Otherwise, it's blue. Let's see. Well, it's an acid-base indigo. You know what? I guess D. I'm not really thrilled with that definition. It is an acid-base indicator, though. Fair enough. Inorganic. Oh, that I can get. Solvent. I don't know yet. I'll come back to that. Acid. Oh, an acid. What makes an acid an acid? It has hydrogen. That's because it releases hydrogen plus ions in solution. Say what, Mr. Dueck? Again, if I go back to my notes on acids and bases, you may recall we looked at, where are we? I'm looking, here it is. Acids release hydrogen plus ions, and bases release OH negative or hydroxide ions. And when you combine those two, they form water. That's why an acid-base neutralization reaction has a product of water. Concentration, you know what? I think it's the measure of the quantity of a substance dissolved. You know, I think H. I haven't given you that word, but I think that's what it means. pH scale, that I can get. A set of numbers that measures acidity levels, sure. Solvent. Okay, I did this one, right? Oh, I did this one. By the way, this here would be a base, not appearing in one of my words. Turns red in acid. I think that's litmus, one of my words. So I think a solvent is a liquid capable of dissolving other substances. So I think it's Dueck, DBF, CHE. 1 mark each. Name the following compounds and indicate whether each is an acid or base or neither. Well, acid, acid, base. What are they called? H2SO4? Mr. Dueck, you said naming was... It's right from the back of your formula sheet. Sorry, of your periodic table sheet. If you look on the back, H2SO4 is sulfuric acid. I told you, I'm not going to ask you to do the naming, but I'll ask you to recognize the ones that are on your sheet. And this is hydrochloric acid. What about CaOH, Mr. Dueck? That's not on my... Yeah, it is. It's calcium. Is calcium multivalent? Do I need Roman numerals? Nope. Hydroxide, because OH is hydroxide. This is a polyatomic ion. So the ide, well, not the ide rule, the metal keeps its name. The non-metal, you either use the ide rule if it's an element, or if it's a polyatomic, use the name. Complete the following chart. Okay, litmus. In pH 4, blue turns red, red stays red. Litmus in pH 10, blue stays blue, red turns blue. What about right in the middle? Do you remember we did the lab, and we may have noticed this actually. When you're at a pH of 7, what's halfway between red and blue? Turns out it's kind of purpley. And I can show you a good picture of that. Here was a completed spot plate. You can see red, this was an acid. Purple, this one was fairly neutral, and we were getting bluer and bluer as we were getting more and more basic. Oh, and also there's bromothymol turning green, yellow, blue, green, in something that was pretty close to neutral. Oh yeah, I remember that now. I guess, by the way, looks like this question is out of 6, 1 mark each. It looks like this question is also out of 6, 1 mark each. Turn the page. Balancing equations. Oh, acid, base, water, and this is a salt. Did I crisscross right with KBr? Yeah, K is plus, Br is minus. Okay, now I need to balance. How many Ks on the left? Change colors, Mr. Dueck. How many? Oh, you know what? I think this is balanced. Let's see. 1K, 1K, 1H, 2 H's, 2 H's, 1 Br, 1 bromide, 1 oxygen, 1 oxygen. This is balanced. So this I'm only going to be making worth 1 mark because all you had to fill in was the H2O. Now, B. First of all, let's get the products. Acid, base, OH starts with an H. So one of the products is going to be H2O. That gets you a half mark. The other product is going to be aluminum combining with SO4. Aluminum is 3 plus, SO4, I got to look that one up, is 2 minus. So it's going to be Al2 SO4 in brackets 3. I covered up the plus sign here. I'll put it right there. Okay? That gets you 1 mark. Half mark for that, half mark for that, as long as you have a 2 there and a 3 there with the brackets. If you don't get a half mark. The best you can do on this question is 0.5 out of 2. Now I balance. How many aluminums on the left? 1. How many aluminums on the right? 2. I already think I'm going to put a 2 in front of the aluminum on the left. How many SO4s on the left? 1. How many SO4s on the right? 3. I already think I'm going to be putting a 3 in front of the aluminum over here, and I may do that first. How many H's on the left? 2 plus 3, 5. How many H's on the right? 2. How many O's on the left? Again, don't count these O's. You treated them as part of the SO4, the sulfate polyatomic ion, but there are 3 O's right here. 3. How many on the right? 1. Okay, now we balance. I'm going to start out putting a 3 here because that's going to give me 6 of those, which means I'm going to put a 6 here. That's going to give me 6 of those. Now, it's also going to change the oxygens and the hydrogens, and I'm hoping it kind of takes care of itself. Let's see. I have 2 hydrogens. Oh, you know what? Let's do this first. 3 times 6, 18. 19, 20. How many oxygens? 3 times 6, 18. How many SO4s? Oh, good gosh, Mr. Dueck. You guys are all freaking out. I started out doing this one totally wrong. I apologize, guys. Let me erase all this. This is yucky. I did this backwards, didn't I? That was dumb of me. Let's try that again. You're all freaking out. Someone probably thought they got a candy. 1, what did I say? 2 plus 3, 5, 3, 2. There's 3 SO4s here. Where did I want to put that 3? I wanted to put that 3 right there. Jeez, Dueck. Good gosh. I'm sorry, guys. Apparently, I'm already in Hawaii. Okay, that gives me 3 SO4s. That's better. And that gives me 6 plus 3, 9 hydrogens. Whew. Now, I'm going to try 2 aluminums. That's going to give me 2 of those. That's going to give me 3 times 2, 6 hydrogens, plus the 6 here. Now I have 12 hydrogens, and that's going to give me a lovely 3 times 2, 6 oxygens, and that's wonderful because I think if I put a 6 here, I'll get 12, and I'll get 6, and holy smokes, I'm balanced. Boy, did I botch that one. How would I mark this? So for the stuff I wrote in blue, half mark for that, half mark for the H2O, half mark for getting a aluminum with 2 and an SO4 with 3 for getting aluminum sulfate. Then I would give you 1 mark if you balance correctly, so a half mark for each number that's wrong. So this is worth a total of 2 marks. I wrote the reactions are both of the same type. This is called a acid-base neutralization reaction. If you said acid-base, I'll take that, but it's actually an acid-base neutralization reaction. A couple more and we're done. Oh, I gotta pause the video for a second. I gotta go take something off the hot pot. Slight pause there. I had to do something in my lab, clean something up. Let's keep going. Number 20. This is a metal combining with an acid. So what I'm going to end up getting as my product is hydrogen gas, and then these two are going to combine. Now I have to crisscross properly. So over here in the margin, magnesium has a charge of 2+, chlorine has a charge of -. I'm going to get magnesium chloride, but I'm going to need 2 chlorides. If you got that, half mark for the magnesium chloride with a 2 there, half mark for the H2. Now, let's balance. Oh, you know what? I think to balance, I just need to put a 2 there, because I got 1 magnesium, 2 chlorines. Now I got 2 chlorines, 2 hydrogens. There's the balance, so 1 mark for that. So this question is also out of 2. Oh, B, this is another acid-base reaction. How can I tell? KOH, that's a base. Starts with an H, that's an acid. So it's going to be, as my products, H2O, and the K and the PO4 are going to combine, but I got to crisscross properly first. I'll do that over here. K is plus, PO4, I got to look that one up. Phosphate is 3 negative, so it's going to be K3, PO4, 1. Do I need to put the 1 there? No. Now, let's balance. I have 1K, 3 Ks. I have 1 PO4. I have 1 PO4. I always got to be careful with the H's. 3, 4 H's. I have 2 H's. I have 1 O. Don't count this O. I counted it in the PO4. And I have 1 O. Now I'm a little worried. Will this work? I think I did the physics right. I think I did the math right. Let's see. Well, I got 3 Ks. Put a 3 there. That gives me 3 of those. Now that gives me 3 H's plus 3 H's is 6 H's. Oh, and that gives me 3 O's. Oh, this isn't going to be too bad. I got 6 H's. If I put a 3 there, that gives me 6 H's and 3 O's, and everything else is balanced. Woohoo! So, hey, how about half mark for that, 3, half mark for that, 3, half mark for that, half mark for that. So this is out of 2. That means this quiz totally is out of 2 plus 2, 4, 5, 6, 7, 8. 8 plus 6, that's right, 24, plus 6 is 30, plus 16. So 30 plus 16 is a big quiz, practice quiz. It's out of a total of 46. Give yourself a score at the top out of 46. However, I am not going to collect this. I don't I don't want you to hand it in. I want you to hang on to it to study from. Mr. Dueck, do you want us to hand it in the day of the test? You know what? I'm going to say I'm not too worried about your score on this quiz. I wanted it to be a good study exercise. You don't need to hand this in the day of the test. I'm not going to actually record this mark, but this is for your own personal edification. If you need more practice, if you want more studying, what can you do? Well, remember we said vocabulary crossword. That I do want you to hand in the day of the test. Organic chemistry homework, if you haven't handed that in, that I do want you to hand in the day of the test. But I also said if you want more practice, you can try. Page 251, number 2, 4 to 7 and 11. Page 252, number 1, 4 to 6, 9, 11, 13 to 15, 16 and 17. I'm not going to collect that, but if you feel you need more practice for your test Wednesday, and if you want more practice on balancing equations, you can try from page 252, number 19 and 20. One more reminder. Your test is Wednesday the 17th. I won't be here. If you are absent on Wednesday, please track down my TOC Thursday or Friday to write the test. Oh, yeah. On Friday, December 19th, I'll have a cool, nerdy science video to show you. Otherwise, have a wonderful New Year. Have a very Merry Christmas. I miss you all. Yeah, even you, whoever was thinking, really, does he miss me? Yeah, I even miss you. And I hope you kick butt on the test. Make me proud. Okay?